Assessing normality. Lesson objective: use normal probability plots or QQ plots to assess normality. Suppose that we obtain a simple random sample from a population whose distribution is unknown. Many of the statistical tests that we perform on small data sets, sample size less than 30, require that the population from which the sample is drawn to be normally distributed. Up to this point, we have said that a random variable x is normally distributed, or at least approximately normal, provided that the histogram of the data is symmetric and bell-shaped. This method works well for large data sets, but the shape of a histogram drawn from a small sample of observations may not always accurately represent the shape of the population. For this reason, we need additional methods for assessing the normality of a random variable x when we are looking at sample data. A more specialized graphical display can help you decide whether a normal model is appropriate is the normal probability plot, or sometimes it's called a QQ plot. If the distribution of the data is roughly normal, the normal probability plot approximates a diagonal straight line. Deviations from the straight line indicate that the distribution is not normal. Let's get a visual. Nearly all normal data have a histogram and a normal probability plot that looks somewhat like this example. Okay, so here we have our histogram, and this is what the probability plot, or sometimes called a QQ plot, looks like. It appears to be a straight line. Now this is an example from a skewed distribution. Here we have the histogram, and here's the QQ plot, or the normal probability plot. Clearly this is not linear. A normal probability plot plots observed data versus normal scores. A normal score is the expected z-score of a data value if the distribution of the random variable is normal. The expected z-score of a observed value will depend upon the number of observations in the set. If the sample data is taken from a population that is normally distributed, a normal probability plot of the actual values versus the expected z-scores will be approximately linear, straight line. We will be content in reading normal probability plots constructed using the statistical software package Minitab. In Minitab, if the points plotted lie within the bounds provided in the graph, we have reason to believe that the sample data comes from a population that is normally distributed. We'll also look on how to do this in StatCrunch. It's a little bit easier in Minitab, however. Minitab. This is the data from the first survey, early fall 09. This is the histogram for age, and clearly this is skewed right. This is the heights for the same data set, and here we can see that this is approximately normal. We're going to look at the probability plots for both these and compare. How do you compute the probability plot? Well, the first thing you do is you go to Graph and you go to Probability Plot. Select it. By default it's single. Hit OK. You get this window. Select the variable. Hit OK. And this is the probability plot for age. Clearly we see that this is skewed. These are the bands that Minitab provide, and about 95% of the points should be within the bands, and clearly they're not. This is the probability plot of height. We see most of the data points are within the bands, give evidence that the sample is coming from a population that is normally distributed. This is how we do it in StatCrunch. You first go to Graphics, go to QQ plot. You'll get this window. Select your variable. We're going to do age and hit Create Graph. This is what it looks like. Now, we don't have the bands that we do in Minitab, but we can see here that this pattern here does not fit our linear model. This is the output for height, and we can see that these are following the line pretty close. Population from which the data is drawn is normally distributed if either of the following two conditions generally hold. Number one, the data points are on or near the line and are randomly scattered about the line. Or most of the data points are within the 95% confidence interval bands if you're using Minitab. Thanks for watching.